Hey there, welcome to our video where we dive into a curious problem involving converting doubles to integers. You see, I stumbled upon a failing unit test that led me to discover an interesting quirk with how GCC handles floating point math on different architectures. The problem arises when converting the number 1.234 multiplied by 1000 to an integer, resulting in unexpected outcomes on x86 32 versus x86 64 systems. Now, let's talk about the solution to this intriguing problem. It turns out that GCC uses different floating point math settings for x86 32 and x86 64 architectures, leading to the discrepancies in the results. On x86 64, the excess precision for temporaries is handled differently compared to x86 32, resulting in the seemingly unexpected behavior. By understanding these nuances, we can explain why we get 1234 on x86 64 without specifying any rounding options, and why adding 0.5 before casting to int64_t might be a valid solution. In summary, we've uncovered a fascinating aspect of floating point arithmetic in GCC that influences how doubles are converted to integers on different architectures. By delving into the intricacies of floating point math settings and excess precision handling, we shed light on the unexpected results observed in our initial problem. And with that, we've come to the end of our video. If you enjoyed this exploration into the quirks of floating point math, don't forget to subscribe, like, and share your thoughts in the comment section below. Thanks for watching, and until next time, happy coding!